to get started, you don't have to install Python. You can use Google Colab. You can go to any of these websites and go look for the rocket, click on Google Colab, and that will open an environment that mirrors the file that was shown on the website, but gives you the option to run it yourselves. So I'm going to show you how to install it in a bit, but maybe let's get started first with the basic syntax of Python. So let's make this a little bit bigger. There are three main ways to run Python, and we're mainly going to use one version of that. That version that you can see here already is kind of this Jupyter notebook format. It gives you the option to combine, some explanatory text with code blocks that can be executed interactively. The other way could be a simple text file, so-called Python file, a Python script. And it could also be an interactive console. So if I open a terminal, I could also, let's hope I have it installed. I could also run so-called IPython, which could give me kind of an environment where I could write Python code, for example, print hello world. That's command line. I don't want to burden you with the command line just yet. So that's why we end up in this interface on Colab that you can also run locally. So how does Python work? So it works pretty much like any other programming languages with a few twists, of course. Every programming language has their own quirks. But I guess all programming languages have something that's called variables, kind of some reference to some values stored in the memory that we can access later, where we can change the values. For example, we can assign the value 1 to a variable that we call a, or a string hello that we assign to a variable b. So let's get that running. So that's now stored, and we can reference a and b later. But before that, 2 comments. So everything after the hashtag, or it's a symbol. It's a comment. So it's ignored for code execution, but can be useful to just document for yourself what you've done. While you're relatively free to choose the variable names, there's some things that you should not name your variables because they have some other functionality in Python. For example, true, false values have some value, or return, try, lambda, with, yield. All of them have specific meaning in Python that is reserved. You can, the tragic thing is that you can assign your variables these values, but it's not recommended, and your code will break if you do that. There's also a range of different functions, like rounding, finding the maximum or so, that you also should not name your variables after. So use this just as a reference. What we can do is, well, we have stored the variables a and b, so we can access them in Jupyter Notebooks. We can just kind of type the variable name into a code cell and execute it, and we get this output, what is stored in this variable. And we can also use the print function. So functions in Python they have a name, and we execute them with round brackets. And functions can take arguments, so-called arguments, so inputs for the function. Think of it just as math, like f of x. The x would be your input. In this case, we pass a variable here as input, and that would print us hello into the output console. Variables are so-called objects. This is a way of organizing variables in Python, and every object has a certain type, or is of a certain type, is of a certain class that defines kind of what values can it take, or what operations can be performed on it. So for example, there's an integer data type that of course should only take integer numbers. We can't assign it a string or a float point number. To find out what type our variables are, we can use the type function. The type of A is int for integer, 1 is an integer, and B would be str for string. It's a text of characters. So we can also use these functions to check if my object is, or if my variable is of a certain type. So we can say things like type of A is int. So that would be kind of referencing here this output of the type function, kind of whether whatever this function returns meets our expectations that we write after is. And that would then return true or false, depending on what is the case. And that helps us, these checks, they help us later to control the flow. There's also so-called none type in Python. It just means it's a variable that doesn't have a value assigned. So if you say n equals none, if we print none, we get none, and the type is none type. Yeah, and that would be kind of, can sometimes be the output of a function, for example, if it doesn't produce any output. Most of these objects, strings or integers, they can have some attributes or methods associated with them, which you could, for example, which you can access by name and call with the round brackets. So, for example, for this string B, where we said hello, and our hello was all lowercase letters, there's a function capitalize, which just will capitalize the string. And we can maybe first forget about the round brackets, and this will just access the function itself without executing it. And once we put the round brackets here, we actually get a changed object. Instead of hello, where the h is lowercase, we have the h that is uppercase. There are other useful functions. For example, if you have a sentence, and that is often used, so-called tokenizing of text data, we maybe want to identify the individual words of this object, this string that we store in a variable s, and we use the function s split, and this function actually takes an argument. It takes an argument for what character do we actually want to split on. So we want to split on the spaces so that every kind of word for itself is an element in a list, for example. So, and that output, so I could also just kind of remove this first. If I just execute this, we get a list returned. Lists are identified by these square brackets, and then individual elements that are just the words in this text. And this output, we can always, the output of any function, we can assign to a variable. And we can also use functions to join lists again. So we can take a string dash and want to use this to join the elements in the list together. So here we would get, how are you today? How are you today as a string, but with dashes separated then. In terms of strings, also Python has useful ways to make print statements more beautiful to fill in values with these curly brackets. So let's say we have a power plant here called Reuter West Power Plant, a certain capacity, a numeric value, and a technology. Then we can construct a message. In Berlin, there's a CHP power plant called Reuter West Power Plant. It has a nominal capacity of and then we can also actually do some rounding here. So this would mean we round to 2 floating points. So if we execute that, we get as message kind of the filled in values, and we could change the values here and get something different. So instead of CHP, we would see a coal power plant here. Cool. So that much about working with strings. Basic maths. So Python you can also just use as a calculator. You can do addition and subtraction, multiplying, division. That's all, I think, intuitive and how you would paste it into your own calculators. Exponentiation you can, of course, also do, but the syntax is something that you maybe wouldn't expect. So instead of kind of this form. So what doesn't work is this. This doesn't work in Python. It's not the right syntax. You have to do double stars. So that would mean 2 to the power 4. You can also do rounding using this round function I mentioned at the beginning. What is also useful is to compare different things to one another. And there are different so-called operators that let us compare objects, and that would then return if a statement is true or false. So we can check if something is equal, unequal, bigger than or smaller than, bigger than or smaller than, equal to something, or whether that something points to the same object even. So for example, we would say 2 less than 3. I would expect that this is true. Energy equals power, so 2 strings, they are not the same. And then we have also a few more complicated cases, so maybe a quick show of hands. So if I write is 2 unequal to string of 2, who thinks this should report a true value? Who thinks this should report a false value? Okay, pretty even. So it actually says true. So it means the two integer is not the same as a string integer. Same question here, whether 2 is equal to 2.0. Who thinks this should be true? Okay, who thinks this should be false? Okay, it's pretty even again. So this is actually true. So, and this is to do with kind of the types are also form kind of groups of different types, and 2 and 2.0 are both numeric data types, whereas 2 and string 2 are 2 completely different data types. And that's why kind of one reports true, one reports true if we say it's unequal, and one reports true if it's equal. So say we want to check multiple things, then we need so-called Boolean operators that let us connect different different conditions at once. So we can combine if 2 statements are both true with the AND operator. We can use the OR operator, and we can also negate logically with the NOT operator. So for example, we have here a case 1 is bigger than 2. This one is obviously false, and this one is true. So we have false and true. So this will give you false. Well, not sure why it's slow. Should be slow. It will give you false because one of these statements is false and not all of them are true. No? It's maybe poor internet connection, not sure. And let's swap to a local version of this. Okay, so this is just all the same, just a local version of the notebook. So I'll make that larger in a moment. Once we are at the point where we were before. Hope that's large enough, I think. Yeah. Okay, so kind of one of these statements is false, then the whole statement is false. If we correct the statement, then we get a true. And if we go back to the original statement, but say only like this left has to be true or right has to be true, then this will also return true because at least one of them is true. And we can also build in a not here. Even if we have kind of two true statements, we're expecting false here, then we get true in the end. So that doesn't make a lot of sense if I talk you through it, but it makes sense if you just go step by step. Logical operations can be, it can create knots in your head. Okay, but what do we actually need all these checks for? We need them to control somewhat the flow of our program. And this is where conditionals come into play. So conditionals, in this case, if else clauses, if elif, which stands for else if, and else controls check something, and then depending on the evaluation of the check of the Boolean operator, will execute some code. So that means that with the value that is stored in certain variables like x, we can control whether this cell would print a positive number, negative number, or 0. So for example, if we put in a positive number here, then this cell here will print positive number. If we put a negative number here, we'll say negative number. And if we put 0 here, we get 0. And how it works is like the first condition is checked. If x is bigger than 0, then we know it's a positive number. If that is false, it will jump to the next bit, the else if, and then the else would be kind of the execution of last resort. If none of the kind of conditions we check for were true, then we do some fallback operation. So you see here already one important thing about Python is that indentation matters. So blocks are opened and closed by indenting values. So what wouldn't work, and you can see already quite a bit of red here, is if we put everything on the same level, because then it's not quite clear kind of the relation between the Boolean evaluation, the conditionals, and the code that needs to be executed in these cases is not clear anymore. So indentation is important. And we can also kind of do this in a nested way. Kind of within one check, we do another check. And if kind of the x is bigger than 100, we actually want to print a huge number. Yeah, so let's put 1000 here. Then in this case, we're actually executing this first, and then we actually have the second condition also met, so then we print huge number. There's also a way to kind of do this if-else in a single line without indentation. So say we have a list of words, and we want to print long list if the length of words, so the number of entries in this list is bigger than 10. We want to output long list, otherwise short list. We can do it in this way, where we kind of first look at the if, then at the else, but that is kind of, it's a bit more constrained what you can do with this syntax. So conditionals, if, else, if, elif, else, are kind of one way to control the flow. And then, of course, there are also loops that allow your program to conduct repetitive tasks like iterating over the elements in a list and doing the same kind of operation for all items in it. There are basically two types of lists. There are while loops and for loops. For loops, they iterate over a given sequence of values, and while loops, they kind of continue evaluation until a certain condition is exceeded. For example, if we want to count, then we start with an initial variable. We count until count is no longer lower than 10. So while the count variable is less than 10, we add 1 to the count and continue within this loop. And at the end, we print the value that should then be 10. We can do the same with for example, using range, or we could also just do a list of 1, 2, 3, 4, 5 that would print kind of all the items in this list, one on to each other. The importance here is that Python actually starts counting from 0. So if you want to access the third element in a list, for example, you would have to write a 2, because 0, 1, 2, 2 is the third entry. This is also why here range would be just kind of basically a list that counts the first 5 integer values, so 0, 1, 2, 3, 4. It doesn't include the 5. So we can iterate over lists as well. And then sometimes we're maybe interested in also keeping track of the position the position of an item in a list. So where we can use this enumerate function, we just have our list and wrap that in the enumerate function. And then we iterate over I and the energy carrier, which would give us, when we execute that, first the count, so 0, 1, 2, again counting from 0, the electricity, the carrier, electricity, hydrogen, or methane, and the length function, it would just count the characters in the string. So now we've seen it already quite a few times, this list attribute, list object is one other data structure in Python, which has its own type. If you look for the type of a list object, you will get list returned. And these lists, they have their own set of functions. One of them is kind of sorting it alphabetically, for example. So I think if I just mess with the order a little bit, so it's not already in alphabetical order. If I now sort it, I get back again kind of a sorted version of this list. There's a couple of them, like getting the first item, counting the number of items, reversing the list, and so on and so forth. Most of that you would just, when you need it, you would look it up in the documentation of Python. And for example, you can also just add two lists together. So say we have one list X and Y. We want to concatenate them, make one list of that out of them. We could just add X plus Y, and that would store that in Z. And and that would give us a list from 0 to 4, and then again from 10 to 14. So we have a list, a way of storing data in a certain format. Obviously, we will at some point want to access these values, and accessing values, as in many cases in Python for different types of data structures, works with square brackets. If you want to access the first element, you would write Z0. If you want to access the last one, be Z minus 1. If you want to access the first 3, it would be :3. And if it's the last 3, it's -3:. Things, yeah, you just basically have to learn by heart. And that would just give us kind of 0 is the first element, 14 is the last. The first 3 are 0, 1, 2. We can also check if a particular item is in a list. So we can just look at this list, and maybe we want to know if 5 is in this list. And we can use the in operator here. We can say, is 5 in Z? In this case, it's not the case, so it will return false. But the 4, for example, is in this list. Yeah. So append you would use if you say you have a list from 0 to 4, 0, 1, 2, 3, 4, and you have another object 5. Then you would use append to append the object 5 into the list. If you have 0, 1, 2, 3, 4, and another list 10, 11, 12, then you would use extend. So it's kind of either you're extending with a list, the same data type, or you're extending one item in the list. Yes, exactly. Okay, so Python is full of tricks. So you can work with lists, so-called list comprehensions. You can actually build in a loop into square brackets and say, I want to, for every n from 0 to 5, I want to calculate n squared. It's just a nice gimmick that can be quite useful to write short code, where you, again, like this if-else in a single line, you can do for loops in a single line using this list comprehension. Okay. So lists are a bit limited because you need to know the positions where you stored your data. That's why there's another basic data structure, the dictionaries. There are two. So dictionaries, as the name says, it's kind of pairs of keys and values. So your keys might be a German word and the values might be the English word, or the other way around, like real dictionaries that map words to their definitions or translations. And there are two main syntaxes to create dictionaries. One is with curly brackets and one is with the dict function. So take again our power plant. There's one power plant here in Berlin. It's coal-fired. We can say we have a dictionary where under the key name, we store the actual name. Under the name capacity, we store the value of the capacity. Under the key fuel, we store the actual fuel type of the power plant. And the syntax is just open with the curly brackets, the key followed by a colon, and then end an entry with a comma. The dictionary function looks similar, only that it doesn't have as many quotes. It's a matter of taste which one you really use. And then again, you can now, instead of accessing values with the position, you can access values based on the key. So if we want to know the capacity of the power plant, we can say the capacity. And again, we can also check if a certain key is in the dictionary, whether fuel is in the dictionary. Maybe I could also have a title here, and then it would return me false. What happens if you try to access a key that doesn't exist? you will get thrown a so-called an error. So let's see. So we actually don't have technology given. So what happens? Well, we get an error message, and that's also one important thing to look closely at error messages. My tip is read it from the bottom to the top. So the bottom tells us key error technology. So this was the key that we were looking for that wasn't found. And then as we go further up, you can actually see a reference to the line where this error occurred. So it's trivial in this case because our code cell just consists of a single line. But imagine you have 1,000 lines of code or 10,000 lines of code. You get actually kind of a trail back, like breadcrumbs, a trail back to where your error happened. And you can also kind of capture these errors in this way with try and except blocks, where you try something. If you fail and expect something like a key error, you can do something else, like, for example, key error encountered, but not actually fail with this error. So one other way to kind of avoid this error would be to use the get function, so one built-in function of the dictionary, where you say, okay, and this is in principle very similar to the square brackets, where we say get, it's a function, so hence the round brackets. Let's try to access the technology. And if that technology does not exist, then we fall back to OCGT, Open Cycle Gas Turbine. Yes. So there's someone online wanted to ask a question. I don't have particularly good sound set up, but let's see. I think I can understand you, but nobody else.
Okay. Yeah, I wanted to ask if for the try except, do I have to know which error can occur, or is it just for every error that can arise?
You don't have to know, but it's good practice because otherwise, I mean, you're writing this except code. You would, first of all, you would use it rarely. It's not good code style to work with try and except blocks. And you would think this basically also works. So you don't specify that. But say I have, I could be kind of specific and say another type of error. So I expect I implemented a fallback for the not implemented error, but I actually get a key error, and I didn't think about the key error, then this code should still fail, which is good if I'm specific. If I'm not specific, then it says key error encountered or does some things that is made for the key error, but I actually don't know whether it was some other error that I encountered. So that's why kind of this it's called bare except, because it doesn't specify anything. It's quite dangerous in coding because you don't actually know what errors you can expect here, and it's likely that there are errors that you're not catching with this except block.
Okay, thanks.
Okay, so fallback, we don't have technology, so that's what then we get out the OCGT. And we can set new entries to the dictionary by kind of the same syntax that we would use to access the values, but then with an equal sign, assign that to the dictionary. And then if we look at the full dictionary, instead of 3 entries, we actually have 4 entries. Four entries, name, capacity, fuel, and technology. Yes. Okay, so let's go back. We have to think of something else because we added now the technology. But say I want to access country. So I don't do anything. I actually run into an error, and the program would just exit. And would say, let's say, sorry, I failed. please fix the bug and re-execute. But sometimes it may be kind of a small error that we can handle otherwise, that we know how to handle when it occurs. Then we would say try accessing the country. But if you encounter a key error, then actually assign to the country Germany. And that would essentially do the same as this function does. But here we, of course, have a little bit more freedom. We could also say, I don't know, something random. Country is equal to Germany if the name, if it's Reuter West or unknown otherwise, and we could write just random code here to handle the error that we encounter in this try block. So it's kind of a way to handle error messages gracefully, but they should be specific because you could enter here. I mean, the code you write here is specific to a certain error that you're expecting, but if the error is something else, then this code might be wrong and might not resolve your error. I don't think it's. I mean, for example, if we expect here some other error, just printing x, then we would still run into the error. So it's a bit different, I would say. But I'm not sure if I understood your question 100%. Like this. You mean like this? There's a difference because in this case the program would continue. In this case, the program would stop completely. In this case, it's just ignoring the error and continuing with the rest. And it could be that kind of accessing this value is maybe not essential, so whatever comes next is independent and we don't worry about it. So that's the difference. Okay. So combination of dictionaries with for loops is we can use this items functions to iterate over key value pairs. So for KV in the items would give you just a print of the kind of name with the name with the actual name, capacity with the actual capacity, and so on and so forth. Okay, so maybe we want to, let's say we have some block of code that we want to run for different countries. We have one dictionary with different countries, and we don't want to repeat ourselves. And there we can use another code structure, so-called functions. It's kind of a block of code that is the same, but generalized for a set of different inputs. So for example, and the syntax looks like this. We define a function with a def. We can say hello with round brackets and the colon, and then indent something. This function should return something like hello. Okay, this is an easy function. And we can define it. This will not do anything yet, but then we can execute this function, and what this will do, it will return hello. And whatever is returned in the function, we've used this before, we can also store in an object and access that in a later point. But the real useful thing comes into play when we actually want to process some inputs. For example, process a name and greeting a specific person. We maybe want to say return hello plus the name, and we take as function argument a random name. So, for example, if we want to greet Bob, then we can execute the function say hello to, and then pass the input, the person, the string for the input that we want to greet that we are processing within this function. And it could be Bob or Alice or Gustav or whoever you want to greet. And this is a so-called positional argument. I could have multiple arguments. So for example, I could say the greeting is Guten Tag, and actually we want to use the greeting. And oh no, that was a bit too quick. We could have two arguments, a name and greeting. The first one is the name, the second one is the greeting. So if we want to say Gustav and hi, we would get hi Gustav. So the arguments are processed. And sometimes, so these are positional because depending on in what order you put them in, it's expected what kind of input it is. And there are also so-called keyword arguments. These are optional in comparison to these positional arguments, which are always compulsory. So we could, for example, have a function say hello, where we definitely want a name, but then it could be either in English or in German, and the default would be that it is in English, but we want this function to also be able to say hello in German. And there we have an if-else block. Say if German is true, so that's shorthand here for German equals true. We want the greeting to be Guten Tag and otherwise hello. Then we can use this in the default settings. We only provide the name and ignore about the other argument that would default to English. And then we can also say, if we want to say hello to Gustav, then maybe it should be in German. And then it says Guten Tag, Gustav. So two forms of arguments, positional arguments, keyword arguments, and the keyword arguments always come last. Okay, so we're almost done with this intro. But there's kind of one more complicated aspect to look at, and that relates to what we do within these functions. They're so-called pure and impure functions, and a pure function would not modify any of the objects that we pass here. So, yes. Okay, yeah. So that's a good question because unlike many other programming languages, Python is not very strict about the data types it receives. So you're not defining that. You can document it, and there are also ways to enforce it, but these are more recent developments. So it's not necessary at all to specify what data type is expected here. It's in Python, it would be kind of what you often see in Python programs. You would see something like maybe an assert statement is instance name string. And then you can say the name must be a string. Or German must be a Boolean, bool. So you can do these manual checks. You can document that since a few Python versions ago, you can document this in the function so-called signature. You could say it should be string or Boolean. But if I now give you a number here, which is obviously not a string, then it doesn't fail directly. It only fails in kind of when we actually want to do something with it. And we can also just kind of capture that and convert our input to a string. And this is perfectly fine. It doesn't, even if we pass, even if we define or we document here, this input should be a string, by default, it will not complain if it actually gets something else. And then it's just a matter of whether the code that you write in this function can handle this input and might fail if it cannot, for example, if we don't do this so-called typecasting conversion of a number to a string. There are extensions that let you enforce that, whatever you document here. Yeah. Okay, pure and impure functions. So say you have a function that gets some argument, and you use this function pop, which removes the first item from the list. So here we do something with the input that lives on beyond the execution of this function. So I will show you that. So let's say we have this list of names, and we have this function name remove last from list. Then after we have executed this function, we only have two names remaining. And if we re-execute the same function, because our names are now only two entries, we can actually also remove the kind of now last entry. So we're left with only Max in the name list. So this, I mean, this might be desired, but it's bad if it's not desired and happens. So what you can do is you can write a pure function where you just say, okay, whatever input I give, I don't want to modify it. I want to actually make a copy of that, and whatever I do with it, I want to return as a new object. So this is the same. It only makes a copy of the original list. So now if we take again our original list of names, we execute this function. This returns Max and Marta, but our names are still Max, Marta, and Marie. We can assign to this function, so the output of this function, two new names, and then still our names are 3. The new names is just the 2. And that means kind of we can execute this function as often as we want. At the end, I will still have the 2 names. Okay. Tobias, you have a question?
Yes. Do I need to use the dot copy function because I set a new variable and I'm just linking it to the new list?
Yes, you need the
And
copy.
I'm returning.
Yeah, so you need the copy. Otherwise, you just kind of the equal is always just pointing to an existing object. So that I can show you. So in this case, I just kind of reference the object that is stored under input list, also under new list. So now this would again be an impure function. So actually, I remove the names, the last name from the original names object. So the copy is necessary.
Okay.
Good. All right. So far, so good. So that's the first notebook of Python. Next week, we're going to learn about our first package. And once I'm done talking, there are a few exercises that you can go through. And I would, of course, recommend that you try to do them without looking at the solutions first. But if at some point you get stuck and want the solutions, you can just go here onto the solutions. And it's also designed in a way that you can just look at the solutions of individual tasks so that you don't get tempted too much to look at all the solutions first. There's one more important thing that we didn't talk about. It's like, how do you get there on your local computers? And you may have seen I'm not using Windows. I brought a Windows laptop with me because let's see with a show of hands how many of you are using Windows? Anyone using Linux? Mac? Okay, all right, good. There's so the problem is all your computers are different. You will all have different problems. I'll try to help you as much individually as possible. And there are also a few different sets of instructions that you can find on the welcome page, starting from how do I get the code and how can I set up or how can I install everything. And my recommendation would be to work with Conda in this course. Conda is a package manager in Python. So it gives you a Python installation, and then it also manages different environments, different isolated sets of specific versions of packages. So we might be using different software packages like Pipestar, like Pandas, and so on, with specific versions. And these package managers, they kind of allow us to install them easily and also kind of manage that they are compatible with one another. This is my kind of recommendation for you to go through step by step. I will give you one way how to do it on the Windows laptop, because that's the majority of you. But basically, the idea is that we all have a more or less a shared environment. So it's hopefully the same for all of you, same environment, same software packages for all of you. And I really recommend kind of going through this step by step on your own. But I will now, for everyone, just go show one way. And the first step for everything is how do I get the files? So Colab was easy. It opened kind of interactive environment online. But if I want to have these files locally, I can also go to the download button and download the IPython notebook. I actually am going to switch for that to the other laptop. Make sure. Oh, so it's not great. Okay, so how do I get the files? So if I'm interested in the introduction that I just went through, I can just download this IPyNB file. So IPython notebook is just the kind of Jupyter notebook file format. And I hope that's okay. That's different on Windows. Of course, it's different on Windows. So we can save it under downloads, for example. And that's already something that we have stored there. About the installation, there's kind of Anaconda, which is a Python distribution, which works relatively easily on Windows. If you follow this getting started link, it's not what I want. Then you will get different instructions for different operating systems. Most of you, if you're a beginner, you will want to work with the anaconda distribution and not miniconda. And then you can say, okay, I want to install anaconda. I have a choice of operating system. In this case, I want Windows. There's a nice video that guides you through the installation process. But the first step that you have to do is to go through the download window. And actually, since recently you need an account, but you can also just use a throwaway email. So I created one, and I'm logged in now and can go to the just download the distribution. It's about 1 gigabytes worth of files, and you can this will give you an exe file that will guide you through just the regular installation process on Windows, just an exe file. And once you have installed that, you get a software item that could be called Anaconda Navigator. It's kind of your interface to working with different environments and your gateway to installing the environment for the course. I hope it opens sooner or later. Sorry, this laptop is a bit old, so it's a bit slow. But we can do something in between. So one other thing, so we need this anaconda, but we also need a file, so-called environment file. It's a kind of conda-specific format, so-called YAML format. It's a text format that specifies kind of a list of different packages that should be installed. There are links for your different operating systems here. So pick the one that is relevant for your operating system. So this file is kind of a file with specific versions already installed. So for example, we can go here, look for pandas, and there's a specific version 2.3.3 that should be installed. So this is where you get, if you click on the link, and then there's a download button here to download this file. And that will land in your download folder. And that is something that you can reference then later in Conda. So there's different ways. If you're not like familiar with the command line, it's probably easiest to do it through this graphical user interface, where you can go to environments. And these are really different isolated sets of packages. And go here on the import button and select from your downloads folder the log file, the environment file that you just downloaded. And then you just click import, and that process will take a while. So it can take maybe 20 minutes or so, depending on how quick your computer is and how quick your internet connection is. I already did that, and that's an environment that is now kind of available to me in the command line. That's where we go to next. So this is one interface for Anaconda. The other interface would be your Anaconda prompt. It's a command line specific to Anaconda. Exactly. And that allows you, first of all, let's make this a little bit, I hope it's big enough. but it allows you to just navigate in the terminal. There are also some hints on what are the basic commands to navigate in the terminal. But for example, we can cd, change directory, into the downloads folder where our Jupyter notebook is located. We can activate our environment that we installed. And that is something that we have to do every time we open a new Anaconda prompt. You can see the environment that is activated initially is the so-called base environment, but we can also just say conda. First of all, maybe we can check what environments are installed with conda and list. You can see there's a base, and then there's this Win64 log environment. So we can say conda activate one of these environments, so Win64 log. And now what changes is that in the round brackets on the left, we can see kind of the name of the environment that is loaded. So that means we have now access to the packages that are in this environment. And we can now start using software, for example, launching a Jupyter Lab instance. What is a Jupyter Lab instance? It's very similar to this interface that we saw in Google Colab. And it will actually also open in a browser. So when I execute that, the command is Jupyter Lab. What will happen, hopefully, will be a browser window opening. With an overview of our downloads folder. For example, the 01 workshop Python. You can double click on it. And this is exactly the notebook that we have gone through. You can go to individual code cells, hit the play button. You can also use Shift Enter to go step by step and execute the code there. And if you manage to get there, then you're already very far and you're already set up for the rest of the course to work with all Python packages that we're going to cover, because this environment is made for the whole course towards the very end. And yeah, if you want to stop working on this, closing the tab does not suffice. It's still running, and I could still kind of reopen this browser window, but you can terminate it when you just close the prompt, and then it's not running anymore on your computer. So that's one way. The other way, let me just think if I want to do that. No, yes, I want to do that. So the other way to install the environment without this Anaconda Navigator user interface and I think that's would be to use a set of different commands. So for example, we can again change to the downloads directory. And then we actually use conda environments. For example, we can say we want to create an environment, conda env create, from a particular file, namely this Win65 log YAML file. And I'm not going to execute that now, but this will essentially do the same as in the navigator interface, where you click on the import button. It's exactly the same process. So choose something that you like, and the first steps are always a bit of a trouble, but I will stick around until kind of 7:45 to help you, but I would recommend that you take a short break, 10-15 minutes, or however you feel, or go home if you feel like it's already late enough and you want to do it at home. That's also fine. I would at this point conclude the online session for today. Just to say, we meet again next week at same time, 4 o'clock on Thursday. We'll go through kind of looking at more geographical information systems. So this week we looked at the time series. Next week we're going to look at kind of where can we actually build wind and solar power plants, and what software do we need for that. In terms of software, we're going to look at NumPy and Matplotlib, one library for processing numerical data and one library for plotting numerical data. These are kind of foundational data Python packages that that are not relevant only for energy system modeling, but for anything else. Yes, so I'll try to keep an eye on the chat to try to help if there are any questions online as well. But I will at least take a 10-minute break now. Okay, I'll stop the recording now and then